Hello and welcome, guys. I'm Melvin Kollie. Today we will be discussing the Bernoulli differential equation. This is very useful to engineers and mathematicians and physicists. For civil engineering, we talk about fluid mechanics. We do a lot of stuff using Bernoulli differential equation. Um, so right now it's like 2 o'clock in the morning in Miami, and I was sleeping and I woke up to do a lecture video on Bernoulli differential equation. This is a very special type of equation, okay? And this equation was introduced by Jacob Bernoulli in 1695. In 1695, he talked about this equation. So I'm going to give you some idea on how you can solve this equation. So guys, please watch the video, like the video, and share the video. Um, Thank you so much, and let us get started. Okay, so as I said earlier, now we have to know this Bernoulli differential equation. Okay, so remember this is any real number other than this is so other than 0 or 1. So as I said earlier, the parameter n in this case for Bernoulli differential equation, the parameter n is any real number other than 0 or 1. Okay, and what make these equations very special? They are non-linear differential equation. So this was introduced by a Swiss mathematician in 1695 by the name of Jacob Bernoulli. Now, this equation can be expressed in the form, let me erase this one. Okay, erase. This equation can be expressed as perfect dy by dx plus p of x times y will be equal to q of x times y raised to the n. So this portion makes this expression, this equation, different from first order linear differential equation. So this n is a parameter, and this parameter is any real number other than 0 or 1. So take that into consideration. So in case we have for our question A, we have y prime plus 1 over x times y is equal to 1 over y. Okay, so what I'm going to do, I'm going to erase here. Okay, let me erase all and rewrite the equation. Clear all. Okay, so we have A y prime plus 1 over x times y will be equal to 1 over y. So I can rewrite this equation as dy by dx plus 1 over x times y will be equal to y raised to the negative 1. So now I know that this is my n. So make this substitution. So v is equal to y raised to the 1 minus n. So v will be equal to y 1 minus n. And there is negative 1. So v will be equal to y raised to the 2. So if we have v equal to y raised to the 2, we know that y squared is the same as equal v. So if I turn here, I want half and 1/2. I notice that this can cancel out. Y will be equal to v raised to the 1/2. So we have to keep this here to not forget. So what I'm going to do right now, I'm going to replace in the equation wherever I see dy by dx, I'm going to differentiate here. So dy by dx will be equal to, if I differentiate, half v, and then I subtract 1. So half minus 1 is minus half. I'm differentiating dv as respect to x. So what I'm going to do, wherever I see dy by dx, I'm going to replace that with this. And wherever I see y in the expression, I'm going to replace that y by v raised to the half. Okay, so wherever I see dy by dx, I can write I'll have v raised to the minus half dv by dx plus 1 over x times y. Wherever I see y is v raised to the half will be equal to, wherever I see y is v raised to the half. But remember, this y is raised to the negative 1, so times negative 1. Okay, so I will have half v raised to the minus half dv by dx plus 1 over x v raised to the half will be equal to negative 1 times this v raised to the negative half. Okay, so I'm going to erase this side of the ball to have space. So this is very important, guys. Bernoulli differential equation in physics, in engineering. I love this equation so much. Okay, so now you can see that I have this term. So what I want to do, I want to be able to multiply here in a way that I will only have dv by dx. So I have half. So I'm going to multiply by 2. I'm going to multiply by 2 because 2 times this 2 can cancel. And then I have v raised to the minus half, so I will multiply by v raised to the positive half. Why? Because this expression times this expression, this 2 can cancel this 2. V raised to the negative half times v raised to the positive half will go out, and I will only left with, I will have only dv by dx. So now I'll have dv by dx, because this term we cancel out this. So if I multiply 2 times this one, will give me plus 2 over x. 2 times the 2 over x, and then v raised to the half, and v raised to the half. So if I simplify, I will have v only. So in most cases, the second term will always be v. So here I will have v only will be equal to, now 2 times this is 2. What happens if I multiply this and this? I simplify and this goes to 0, v raised to the 0 is 1. So now you can see that this equation is in a linear form. So what I'm going to do, this is the power of Bernoulli equation. So what I'm going to do, I'm going to consider my f of x e raised to the integral of 2 over x times dx. So if I put the 2 out, the integral of dx over x, and this will be equal to e raised to 2. The integral of dx over x is the ln of x, and this will be equal to e raised to, these 2 can come up here, so I will have the ln of x squared. So what happened is ln can cancel this e, so I will have x squared. So what I'm going to do now, I'm going to multiply this whole equation by x squared. So I will have x squared times dv by dx plus 2 over x times v will be equal to 2. Okay guys, so I'm going to clear down this side of the ball to have space. It is 2 o'clock in the morning in Miami, Florida. Normally I wake up at 2 and I stay up to 5:30 in the morning, and I take 1 hour nap and get ready to teach my classes. I have tutorials. Okay, so now I'm going to multiply. So this x squared times this term, I will have x squared dv by dx plus, now x squared times this x will cancel one of this x. So I will have 2x v will be equal to 2x squared. So what I'm going to do, you know that this is the derivative of this. So on d of x here, I will have x squared times v will be equal to 2x squared. So take the integral and add on dx. So this derivative can undo this integral. I will have x squared times v will be equal to 2. If I integrate this, I know from your calculus too, you can write this guy like this, plus some c. So you notice that yes, so this is 3, sorry. So we put this 2 out, so we add 1, and this is what we have plus c. So what I'm going to do, I'm going to divide this term by x squared, x squared, x squared. So this term can go out. So v will be equal to 2 over 3, and this s cubed is s squared, so it becomes 3 minus 2. So here we have x plus c x raised to the negative 2. But remember, I'm sorry, erase this. Perfect. So remember, what is v? We said y is equal to v raised to the half. So if y is equal to v raised to the half, if we square both sides, that means y squared should be equal to v. So wherever I see v, remember this. If we have this one, y is equal to v raised to the half. If I time here by 2, and I time here by 2, this can cancel this, so I have y squared will be equal to v. So in other words, v is equal to y squared. So wherever I see v, I put y squared is equal to 2 over 3 x plus c x raised to the negative 2. So what I'm going to do, I take the root on both sides, and I take the root on both sides. So y will be equal to plus or minus the root of 2 over 3 x plus cx raised to the negative 2. And this becomes our solution. So in case we were given maybe some initial value, maybe x is equal to 0, y is equal to 1. So if we have some initial value, you can also substitute to find your particular solution. Okay, so I hope you remember this step. Okay, boom. So let us go to the second problem. Clear or join. Perfect. In case we have for b, we have y prime is equal to 5y plus e raised to the minus 2x 1 over y squared. And then we have y of 0 is equal to 2. This time around we have some initial value. So I'm going to rewrite this one as dy by dx minus 5y will be equal to e raised to the minus 2x times y raised to the negative 2. Okay, so this is the same as this. So in other words, my n here is negative 2. So v is equal to y raised to the 1 minus n. So v is equal to y raised to the 1 minus n is negative 2. So v will be equal to negative times negative is positive. So 1 plus 2 is 3. So if we have y cubed equal v, I can take one check both sides, the inverse, so that this can cancel out. So y will be equal to v raised to 1/3. So please keep this. So what I'm going to do now, if I have y is equal to that, if I differentiate y, I'm going to get dy by dx is equal to, now differentiate this guy. So I will have 1 over 3 v. Now this minus 1, so minus 3 times minus 1 minus 3 plus 1 minus 2/3. So I'm differentiating v as respect to x. So now wherever I see dy by dx, I write this expression. I'm sorry, there's a heavy downpour of rain right now, so I'm sorry for the noise. So you have minus 2/3 dv by dx. And then minus 5 times y, minus 5 times y. What is y? Y is v raised to 1/3. And then will be equal to e raised to the minus 2/3 times what is y? Y is v raised to the 1/3 times -2. So in other words, y here is -2, so it has to affect what is coming here. So I will have 1/3 v raised to the minus 2/3 dv by dx minus 5 v raised to the 1/3 will be equal to e raised to the minus 2x times v raised to the minus 2/3. Perfect. So what I want to do, I want to multiply this by the term wherein I will only have dv by dx. So since this is free, I'm going to multiply by 3. Now look at the v to raise to the minus 2/3. So I will take, since it is negative, I will take positive. So if I multiply this by this expression, you can see if I multiply this by this, this 3 will cancel this 3. This v raised to the 2/3 will cancel go out with v raised to the minus 2/3. So I will have dv by dx minus 3 times 5 is 15. Now I have v raised to the 1/3 and 2/3. So 2 plus 1 is 3. 3 divided by 3 is just v. E raised to the minus 2x. And then I'm multiplying it by 3. So yeah, I have 3. And then this v raised to the minus 2/3, positive 2/3, just go out. So now I have this. So what I'm going to do, two things I want to keep, my initial condition and my substitution. So I'm going to write it right here so that I cannot forget. So I'm going to clear this side of the ball to have space. So guys, I hope you stay safe out there. Perfect. Okay, so I want to find my r of x is equal to e raised to the integral. Now I consider this guy minus 15. So minus 15 dx. So if I integrate that, I will have e raised to the minus 15 x. So what I'm going to do now, I'm going to multiply everything by this equation. dv by dx minus 15 v will be equal to 3 e raised to the minus 2x. So if I multiply, I will have e raised to the minus 15 x dv by dx minus 15 v e raised to the minus 15 x will be equal to 3 e raised to the minus 15x. And then, okay, so look here, we have e raised to the minus 15x times e raised to the minus 2x. So I'm going to add. And so I'm going to add here. Perfect. So 15 plus 2, 17 minus 17 x. Okay, so look here. This derivative is this. So I'm going to write dx times e raised to the minus 15x times v will be equal to 3 e raised to the minus 17x. So what I'm going to do, take the integral r dx and then r dx. So I'm going to erase the other side of the ball Don't have a space. Okay, perfect. Okay, so this derivative will undo this integral. So I will have e raised to the minus 15 x v will be equal to 3 the integral of e raised to the minus 17 x. Let me clear this. So I have e raised to the 17x dx. So if you forgot, you can integrate this one by saying let u equal to minus 17x. So du will be equal to minus 17 dx. So minus 1 over 17 du will be equal to dx. You saw this in your calculus classes. So minus 15x v will be equal to 3 the integral of minus 1 over 17 times e raised to the u, the u. So if we put this out, minus 15x times v, we have minus 3 over 17. E raised to the u du is equal to e raised to the u plus c. And what is u? Minus 17x plus c. So what I want to do, I want to divide every term here by e raised to the minus 15x. Every term by e raised to the minus 15x. Every term by e raised to the minus 15x. So this guy can cancel out this guy. So v will be equal to, now look here, if this minus 15x goes up here, we will have positive 15. So minus 17 plus 15, we have negative 2. So I have minus 3 over 17 of e raised to the minus 2x. And then when this term going up, it changes to positive. So I will have plus c e raised to the 15x. So guys, I'm going to erase the other side of the ball. So there's a lot of applications in phases, in fluid mechanics, for civil engineers. We use this. Okay, so okay. So what I'm going to do now, remember what is the value for our v. So we said y is equal to v cubed. So if we simplify, we have y cubed will be equal to v. Okay, so wherever I see v, I can write him as y cubed will be equal to minus 3 over 17 e raised to the minus 2x plus c e raised to the 15x. Now, let us look at our initial condition. Our initial condition says x is 0, y is 2. So y is 2 becomes 2 to the third power. X is 0. So you know that 2 times 0 is 0 and e raised to the 0 is 1. So this whole term will just be negative 3 over 17. And this is 0. So e raised to the 0 is 1. 1 times c is plus c. So c will be equal to 2 to the third is 8 plus 3 over 17. And our c here will be equal to, so if you simplify, we will have c will be equal to 1 over and 39 over 17. Let me erase it. I'm sorry. Okay, perfect. Okay, so now we know the value of C. So what I'm going to do, I'm going to erase this side. Perfect. Okay, so let us go back to our equation. Y cubed will be equal to minus 3 over 17 e raised to the minus 2x. We know the value for C now. C is 139 e raised to the 15x, everything over 17. I'm sorry. So when the denominator are the same, we can simplify. Y cubed will be equal to 139 e raised to the 15x minus 3 e raised to the minus 2x, everything over 17. So what I'm going to do, 1/3. So this 3 can cancel this. So y will be equal to 139 e raised to the 15x minus 3 e raised to the minus 2x, everything over 17, all raised to the 1/3. And this become a particular solution. So guys, this is how you solve this. I hope you practice more and you learn the techniques that we are using here. Okay, so let us look at the next problem. I'm going to clear all. Perfect. So we have y prime plus y over x. Okay, let me choose anything. Let me make it ugly. And maybe, yeah, let me make it ugly here. And say equal to 0. Okay, so let us solve this. So this is what I will do. I'm going to send this across. So I will have y prime plus y over x will be equal to positive y raised to the half because I want to find my n. So this can be written as dy by dx plus y over x will be equal to y raised to the half. So I know that my n is equal to half. So v is equal to y raised to the 1 minus n, which is half. So v will be equal to 1 minus half is half. So in other words, y raised to the half will be equal to v. So here, if I times here by 2, if I times here by 2, this and this can go up. Y will be equal to v squared. So if y is equal to v squared, I know this is my substitution. And then if I differentiate, I have dy by dx will be equal to differentiate that to v. I'm differentiating v as respect to x. So I'm going to write my substitution up here before I forget. V is equal to y squared. So what I'm going to do, I'm going to make my substitution. Wherever I see dy by dx, write this. Wherever I see y, I replace it by v squared. So I will have dy by dx now becomes 2v dv by dx plus 1 over x times y. What is y? Y is v squared. Okay, will be equal to y is v squared, so it becomes v squared raised to the half. So I know that 2 times 1 will give me 2. 2 divided by 2, I will have 1. So I will have 2v dv by dx plus 1 over x times v squared will be equal to v. So I want to do I want to multiply in a sense that I should get rid of this term. So what can I do? I can multiply by 1 over 2v. Why? Because if I multiply this by this expression, these two we cancel this two, this v we cancel this v, and I will have only dv by dx. So I will have dv by dx plus 1 over x. Now this v squared times this, you notice that this v can cancel one of this v, so I will left with times v over 2 will be equal to this v can cancel this v, and I will have half only. So I will have dv by dx plus 1 over 2x. So I'm going to erase this. So here I will have 1 over 2x times v will be equal to half. So let us find our integrating factor. E raised to the integral. So this become 1 over 2x dx. So if I should pull this out, half out, I will have the integral of dx over x, which is the ln. So we will have e raised to the half the ln of x. So we notice that this half can go up here. So I will have e raised to the ln of x raised to the half, so that this ln can cancel this e. So my r of x will be equal to x raised to the half. Now I'm going to erase this side of the ball so that I can have space. Perfect. Okay, so I'm going to multiply everything by this equation. So I will have x raised to the half times everything here, dv by dx plus 1 over 2x v will be equal to half. So if I multiply for the first thing, I will have x raised to the half dv by dx. And then if I multiply, it's like this x is 1 and this x is half. So 1 minus half, I will have half. So I will have plus 1 over 2 x raised to the half. V will be equal to 1 over 2 x raised to the half. So if you look here, the derivative of this is what you have here. So I'm going to have dx times x raised to the half times v will be equal to 1 over 2 x raised to the positive half. So I'm going to take the integral on both sides. I'm on dx, take the integral on both sides. half and dx. So this derivative can undo this integral. So we have x raised to the half times v. Oh, I'm sorry, I need to erase this. Perfect. Okay, so will be equal to, so if I put my half out, I will have the integral of x raised to the half dx, which we know. So x raised to the half v will be equal to half, if we integrating, x raised to 1 over 2 plus 1 over 1 over 2 plus 1 plus some c. Okay, so I'm going to erase this side of the ball. Perfect. So guys, I hope you watch the video, like the video, and please share the video. Okay, so I will have x raised to the half v will be equal to half times, now 2 times 1 is 2 plus 1, 3 over 2, so I will turn it around, so times 2 over 3, and then I will have x raised to 2 times 1 is 2 plus 1, 3 over 2 plus some c. So I notice that this can go out with this, so I will have x raised to the half v. Here I'll have it be equal to 1 over 3 x raised to the 3 over 2 plus c. So to find v, I'm going to divide here by x raised to the half, x raised to the half, x raised to the half. So this can go out with this. So my v will be equal to 1/3. Now it's like 3 over 2 minus 1 over 2. So 3 minus 1 is 2. 2 divided by 2 is just x, plus c x raised to the negative half. But remember, wherever we see v is equal to, y squared is equal to v. So if y squared is v squared is equal to y, so that means if I multiply by 1 over 2, I know that v will be equal to y raised to the half. So wherever I see v is y raised to the half. So this is what I'm going to do. So I'm going to erase this side. So I hope you practice these techniques and be able to pass your differential equation classes. Okay, perfect. Okay, so this is what I'm going to do. Okay, so I already have I'm going to make this substitution. I'm going to make this substitution. So wherever I see v in this here, wherever I see v is y raised to the half will be equal to 1/3 x plus c x raised to the negative half. In this case, we don't have no initial value. So in order to get rid of this, I can multiply it by 2. I can multiply it by 2. So this and this can cancel out. So y will be equal to 1/3 x plus cx raised to the negative 1 over 2 all squared. And this become our solution. So in case I give you initial value and then you say x is equal to 0, y is equal to 1, you can just make the substitution, solve for c, and then you can replace so that you can have your particular solution. Okay guys, so this is it. Next we're going to do some application on the Bernoulli differential equation. So I hope this video will help you. Like the video, share the video, make sure you comment, and I wish you well. So guys, thanks a lot, and please remember to stay safe out there. So see you in the next video.